So timber has been part of Springfield for a long, long time. And this is a slide showing where Springfield is in relationship to the rest of Oregon, and you can see how important wood products are to our economy. Our county still has the most wood products-based jobs in the state. And I want to point that out because we are actually known for our wood products, not necessarily because we are the real home of the Simpsons. But we've been a timber industry for a long, long, long time. Springfield Mill started in 1854 and grew from there and diversified. Weyerhaeuser bought timberland that then became another source of product and started a plywood mill, and we grew from there and branched out into trucking and into fuel, and you can see how all of that has changed over time. And not only did Weyerhaeuser buy forest land, but they also opened a mill. And when they opened that mill, they changed how we dealt with wood waste. And for some of us, we can actually remember wigwam burners. And that's when I thought, the first time I thought that wood was cool, because I liked as a little child to see that fire coming out of the top of a wigwam burner. So many people probably don't know what those are either. But what Weyerhaeuser did is start to reuse that wood waste, and they created pulp and paper, and they had a pulp and paper mill, which is now still a pulp and paper mill. It is owned by International Paper, and they just put an investment into the community so they would keep that industry in Springfield, and that is very important to have our economic base solid, because that's my job, is to figure out how to keep jobs, how to grow the economy, and how to have a stable city. And when they put in the $101.6 million, and I still remember, that's their upgrade of equipment that they are installing. In turn, the city has given them a 5-year tax break. It's called an enterprise zone, if you don't know what they are. And so we are foregoing taxes, property taxes, for 5 years so that that equipment can get up and running, and that we, in turn, are a partner with the private industry and give them that tax break. And that's what we can do as your public officials to help private industry be successful in a new and changing environment. So as we diversified, we also changed over time. And so from the 1940s until now, there were a lot of changes, and we all know what they were. They were everything from recessions to changes in forestry practices. How could we address that? And as mayor, out of our most recent recession, I had to look at what can we do to build our economy? And I'm trying to think of different ways that we can grow jobs, that we can keep our families in the community. What can we do? Because we survive on property taxes. We have a community that needs to grow and be stable. And we need to provide jobs for the people that live in the community. What can we do? And it was about that time that I read which I do every month, is read my National Geographic, and it was a story about CLT and Michael Green. And I thought, oh, well, it's right there. It's right under my nose. We have wood products. We've always had wood products. Springfield continues to grow in the wood products industry, but here's an opportunity not only for us as a community, but as the state as a whole, to grow in another new product, and CLT was that new product. And so I want to quote Congressman Blumenauer to lead by example. So I thought, well, what if we did a CLT project? The city did a CLT project. Well, I would need some partners to do that. I would need to build community support, and that's what that public-private partnership does. We know that we need to do things like upgrade our building codes. We know that we need to have access to a project that everyone can come to, and everyone meaning everyone that could benefit from that project, and also have it as an example to show to the world. But we know that there are challenges around it because, of course, I took off, as I quite often do, enthusiastically thinking, oh, CLT, we can just do this. And then realizing that my enthusiasm far outweighed my knowledge base. So I had to stop and think about what do you do to actually promote CLT? How can we actually have a project? And it was about that time that we applied as a region to be a manufacturing communities partnership. So we got to partner with the federal government. And that side there, that's Dr. Worldney, who is with the U.S. Forestry Department, and Charlie Bratch, who is our BFFF, our best federal friend forever. So he has given us that ability to partner at the federal level and to help us be able to develop CLT, to develop partnerships, to figure out where we go next, to look at advanced wood products, and figure out what we want to do. So it's with their help that my enthusiasm turned into an actual direction. So I also needed to figure out some other partners. So you can look at this whole list. It has the Department of Ag, it has EPA, it has the Governor's Office. And I want to shout out to D.R. Johnson, is Valerie here, I'm just so ecstatic that we have a CLT manufacturing facility within the state of Oregon. And it's been a great partnership with Valerie, and I just am so happy that we are a corner of the entire world market now. And also I want to give a shout out to our Springfield Public Schools Superintendent, it's Sue Reike-Smith. I have also said, Sue, you have got to be here at this conference because you are going to see the people that are going to create the jobs for the kids that are in our public schools now, and that we can advance our career technical education possibilities, because where's the future? We have a future in wood products. We need to capitalize on the ability to have that future for our kids and get them excited about it and do it with a CLT project. So that's where we're at now, and we're looking at where we would put that CLT project, and we are redeveloping an area between Springfield and Eugene on the west, Springfield on the east, and it's along a riverfront. No one even sees it now because it was industrial forever. We won an award for a refinement plan that we have figured out for that area, but the pieces that the city needs to do as an elected person, I have to put in some skin in the game. So we do the infrastructure, we do the bike paths, we do the sewers, and we need to put in a parking structure so we can stay high density. So we can build a concrete parking structure, or we can build a CLT parking structure. So yeah, it's way out there on the edge of, okay, what can you do? But then again, why let that hold us back? Let's just figure out how to do it. So who is the better person to be able to do a parking structure design than a lot of bright and creative minds? And where are they? At the University of Oregon. And the University of Oregon School of Architecture students putting together some designs for a CLT parking garage. And so it's not just, it's a reality. It's going to be a reality. We're going to put out an RFP in the fall, and we will have someone picked this year to actually build not only the parking structure, but the development that goes in around it, which we're hoping for a hotel conference center. So keep posted, because we're going to be looking for those developers through our RFP process. So I want to introduce Judith Sheine, who is head of the architect department and was the visionary to help take us to this next level and to actually design a parking structure for us.
Is it on? Yes, right. Sorry about that. So Christine approached me at the Oregon Leadership Summit, not last December, but the January before that. At that summit, Thomas Manis and then Dean Francis Burnett, who was then Dean of the School of Architecture and Allied Arts at University of Oregon, made a joint announcement about the launch of our new collaborative National Center for Advanced Wood Products Manufacturing and Design, and which we were extremely excited about. And I want to thank Christine, because she was really instrumental in lobbying with the state legislature to get the funding for that center. And I want to thank you yet again for doing that for us, Christine. It's another example, I think, of elected officials working with public universities to advance wood products in the state. So actually, it was Courtney Griesel, who approached me at that summit and said, we want to talk to you and the department about designing a mass timber parking garage. And naively, I said, sure, we can do that. And later thought, can we do that, right? And so I immediately called an engineer. So I had spent, I had been teaching at Cal Poly Pomona in Southern California for 20 some odd years before I came to Oregon a couple of years ago. And I'd been working with Professor Michael Gershfeld, who is in the audience, big wave, Michael, right? Since 2008. Michael's a timber specialist, and we had been teaching interdisciplinary studios with engineering and architecture students, working on the design of timber bridges since 2008. And since architecture students come up with, we'll just say, very experimental ideas that can't necessarily be built, but we don't have budgets, we don't have to build them full size, we build very large models. We were able to experiment with materials that weren't available in the US, like CLT, and with kind of very innovative, we're not quite sure they work, but they're still innovative lateral force resisting systems and things like that. So since I moved to Oregon, Michael has been commuting up here to join me in dealing with these design projects. And so I called and said that we had been asked to do a mass timber parking garage, and I asked if it was actually possible. I didn't tell you guys that I'd done that, right? It was like, I'd already said yes. And Michael laughed and said, well, instead of a design studio, we're going to call it a research and design studio. So we embarked on this enterprise. So we also did find out from Professor Lech Musinski that there was one mass timber parking garage, at least in Sweden. They don't have our lateral issues. They don't have the seismic issues that we have. So a huge amount of what we were exploring was how do you deal not just with gravity loads, but seismic loads in a parking garage. So I think Christine has already talked a little bit about the site. It's a private-public partnership where a number of private developers are working around the parking garage site. And when we started the studio, as Courtney might remember, it was not quite clear what was going to be happening around the site, and it changed pretty much on a daily basis. So we were trying to kind of pin down the exact footprint for the parking garage, which kept changing, and the uses around it kept changing, while we were trying to get the students to understand basic ideas about parking garages and basic ideas about CLT. And for a little bit, it was a moving target. But the site was between a number of things. I think it's clearer in the next slide, which is where their giant P is. It was across from a planned hotel and convention center. There's some housing to the west of it and mixed-use development all around it. And we were told we needed to have an entrance that related directly to the hotel and convention center. So we had a program of somewhere between approximately 400 parking spaces. We talked about putting an event space on the roof. We had talked about this fantastic parking garage in Miami that a number of you may have seen, designed by a Swiss architecture firm, Herzog & de Meuron, which is used as an event space on the roof that is used certainly by architects all the time. And we talked about having an event space that would have a fantastic view of the river, that there had to be an active edge of retail and office, and a link across the street to the hotel and conference center, and also, because that wasn't quite enough program for us, the pedestrian link through the site from one side to another, really splitting the garage into two pieces. So I think that I probably don't need to go through this. Why mass timber? The history of Springfield made a big difference. Our department has been known as #1 in sustainable design in the country since the 1960s, when John Reynolds came to the University of Oregon and started teaching everybody about solar and daylight and all sorts of things. So it seems logical that our department would be involved in an advanced wood product effort with the College of Forestry and with the City of Springfield, which has had a very long history of wood. And this slide, I think, is one that has been passed around from Michael Green to Thomas Mannis to this presentation, but you've seen it before, I think. But mass timber really can make a huge difference in building. Our big question is, could it make a big difference in building a parking garage? So this really took a massive effort, and we ran the studio more like a regular office than I think most architecture studios are in school. So we had a client, an actual client, City of Springfield, who we met with very, very often and were kind of on speed dial with us in the studio. Courtney was great and really on top of things. Not only did we have Michael Gershfeld commuting up from Southern California, at least 4 times during the quarter, but I worked in the studio with Assistant Professor Mark D'Onofrio, who is both an engineer and an architect, and worked in some big engineering offices in Chicago, engineering and architecture practices, Halverstrom, and then in SOM before coming to University of Oregon. And we worked with Michael Gershfeld. We also worked with a parking consultant, Rick Williams, who was the parking consultant for Springfield, a material consultant who was Professor Lech Brzezinski of Oregon State, who taught us all about CLT and the history of it and the uses of it. We had a code consultant because, well, there are a lot of very complicated code questions, not only with the use of CLT, but because of the mixed-use nature of the project. And fortunately, we had a University of Oregon Architecture Department alumni, Samir Makashi, who has a code consulting firm here in Portland. There's also a branch in Seattle. So he came down and told us, much to our surprise, that the IBC 2015 would allow us to build 4- and 5-story parking garages using CLT without doing performance testing, which was amazing to us. We weren't going to be doing performance testing in the 9-week quarter. And an ecology consultant, Professor Brooke Muller, who's also our interim dean now, had taught a parking garage studio the year before, looking at ecological issues surrounding parking garages, which always interests our students. How do you deal with, oil and other kind of toxic runoffs from cars, especially that close to the river? And of course, we had a manufacturing consultant, D.R. Johnson. And we took a trip down to D.R. Johnson last spring, and this is a photograph of our class sitting and standing on the first structural CLT paddle ever produced in the United States. We were extremely excited about this, as you can see, and want to make it extremely clear that we're from the University of Oregon. Apparently they're all they're all, what's the other one? Beavers fans right down there. So you can see the students with the O's everywhere. They were very gracious to us, even though we, of course, come from the rival university. And they also visited the studio a couple of times. John Redfield, who was working on our union building across the street, dropped off a very large sample of CLT for us in the studio and visited. And we also had an incredible amount of interest from our elected officials. Not only did Christine come to a number of our reviews, but we had representatives, staffers from Jeff Merkley's office, from Wyden's office, from DeFazio's office. There was an enormous amount of interest in the studio, which I think basically served to terrify our students, right? Right, so in 9 weeks, we got them to deal with a lot of issues. They had to deal with a client with changing urban design issues, with parking constraints, with structural systems, with the design of a parking garage, and also we made them deal with lateral force resistant systems, at least conceptually to a degree. The one thing we did not deal with, and we're on the quarter system, so the studio only lasts for 9 weeks. We did not deal with moisture control. This was pointed out to us several times on the review, and we do understand that that was an issue we didn't get to. I know that the real project will absolutely be dealing with this and is using, I think, some of the ideas that the students came up with. But, we had 26 students. It was a large studio. We had 9 teams working in this, ranging from 2 to 4 students. Most of them were teams of 3. And the advantage to working with a school project is that you get lots and lots and lots of people thinking about these things. And they don't have the normal constraints of a firm. We don't have budget. We do have gravity, but we don't have budget. We don't have the same kinds of constraints that you need to work with in an office. So the students could really be much freer to explore ideas and test things. And that's really a great advantage of working with an architecture school, is that we can incubate experimental projects that it's hard to do in an office that has to worry about meeting payroll. And anyway, so I'm going to show you very quickly 9 projects that we did. The students tend to name their own projects, and sometimes it's based on things they were inspired by. This project was inspired by Japanese construction and a kind of box kite. And they had an idea of making a project that would look very, 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 very light, even though each of the what seemed to be very small beam and column components are in fact 8x10s, contrasting with really big, massive CLT shear walls. And we had the students explore these at a whole bunch of different scales, including 1/4-inch and 1-inch detail models of various kinds, to begin to explore in more detail how these things worked. This project, Block 1, took kind of the theme of CLT shear walls very seriously in terms of developing into a kind of aesthetic for the project. And you can see here in some of the details that the students really looked at a number of the systems that you've seen over the last over the last day or so, kind of hidden plates and rivet connections, and a number of systems that have mostly been used in Europe, Canada, and New Zealand, and not quite here yet. This project, which they call Transparency 5, was really inspired by the Dameron and Herzog project in Miami, where they decided, a number of you may have seen that project, there's a series of V-shaped concrete piers that go in two directions to deal with lateral forces there. So they did a version of that here using CLT panels in kind of innovative ways to resist lateral in both directions, and with a sandwich system in the roof to deal with some of the detailing problems of connecting that. It didn't really work well with the post and beam system, and in concrete you just make a giant slab. So anyway, we looked at a number of ways of dealing with that kind of system, which is really designed in concrete, and how you might translate into in mass timber into CLT. This project, the new mill, and you can probably see this better when looking at it from the inside. This one we looked at, one of the systems that's been developed in New Zealand, which is a post-tension self-centering system using post-tensioning and split rings to design actually a fairly lightweight system, but using something that in theory would be self-centering and be resilient. These students actually developed a walkway system around the build, partly for safety, but also it will have some advantages in using, in protecting the wood by having something on the outside of the building that can actually help with moisture protection. This project, Momentum, was, the students managed to get a bigger footprint into it, so they managed to get it to be lower. It was total 4 stories lower than most of the others, so we decided it might be the place to experiment with another system that was coming out of New Zealand, which was a post and beam moment resisting system using post-tensioning. And it's probably hard to tell at this scale, but the columns towards the middle and the beams towards the middle of the structure are much larger than the ones out at the edges, because those are the ones that are doing the moment resisting. And the columns are about 3 feet. The beams are really deep, and they have post-tensioning cables in them. And again, we have not tested these in real life, but we thought it was worth taking a conceptual look at these things. This is a view of it from the outside. This one, called the Loom, was another one that decided to look at using the CLT panels in a kind of sculptural way, but instead of doing all of the cross-bracing with CLT, they decided to also look at it in terms of a cross-brace system. But unlike some of the teams that really wanted to keep everything light and did a cross-brace system with steel rods, they decided to do a cross-brace system using more wood as that system with some fairly elaborate detailed steel connections. This one was called Slant. You can probably see why. It was also the only project that decided, instead of having flat parking levels, to actually have a continuous ramp all the way up, and they continued the slant theme all the way through. And a lot of the schemes had courtyards in the middle. Our students are very concerned with daylighting. They also often use the courtyards for a series of water tanks that would progressively wash the effluent from the parking garage before it was dumped into the Willamette River. Again, a lot of ecological concerns, and you can see one of the courtyards here. And they used, again, steel rods for lateral in this one. This is one where they decided to really kind of create a facade out of it. They didn't actually use CLT panels because they felt, because it was basically just, a facade and not structural. They used much, much lighter panels for that, and then spent a lot of time developing, again, sort of hidden steel connections for their connections for post and beams, and again for the lateral bracing system. And this is the last structure, the last of them, Glenwood Parks, where the students developed some ideas about using CLT panels on the outside, both to kind of create a rhythm and a facade in the structure and for the lateral load resisting system. And looked again in detail. This was actually a very large model that I have to pick up tomorrow morning and will yet again fill up most of my car. Some of these models were on display at the World Forestry Center up near the Portland Zoo, where they had an exhibit of wood models. They called us right after we finished the studio to ask if they could have some of the models, so we sent them up there. And the students did some models that were 5 and 6 and 8 feet long to display some of the detailing that they had worked out. And you can see in the section up above, that in 9 weeks, the students did take the project really enormously seriously. So even though I think, we don't expect that in a 9-week project we're going to get to things that actually can be built immediately, we got to the point where Springfield felt that it was feasible and they're moving ahead, which we're very excited about. And we know that some of the ideas that the students came up with are actually being incorporated into the project. So I think it was a great partnership. It was certainly fun for us, right? We are happy that you stuck with us through all the experimentation. We had, as Courtney will remember, and Christine, a very messy midterm review where it seemed like nothing was resolved and everything kept changing. But by the end, I think that we got to actually useful products. And I do want to encourage those of you who are out there who might be thinking of that to work with university groups in this way. We're a kind of affordable way to test a lot of ideas about how you can actually experiment with things. And students tend to be a little bit fearless, which is kind of great. And you really don't know what they'll come up with. But, the students who are coming out of our program now, I know of at least one of my recent graduates here, are now moving into offices, especially in the Pacific Northwest, and convincing those offices to do projects in CLT. One of my students who graduated in 2014 is in an office in Seattle and sent me photos about 2 months ago of a project with CLT in it that they're building in Southern Washington. So I think that, our students were wildly enthusiastic. We couldn't believe so many students wanted to take a studio focused on a parking garage, which usually is not the most exciting project, but the mass timber thing has really caught on. And I do encourage those of you who want to experiment to work with universities. It will benefit you, but also it trains the next generation who are now going into offices and trying to get everybody involved in this. Thank you.